From above, a vernal pool might look sort of just like a big old puddle, but beneath the water's surface the vernal pool is teeming with life. In this short video, we will look at the life cycle of the vernal pool through the life cycle of two of its most important inhabitants, the wood frog and the spotted salamander. But to begin, let us define a vernal pool by taking a look at what a vernal pool in central Vermont probably looks like right now, today. It's April 2nd in central Vermont, and despite my wishes, there's still quite a bit of snow on the ground. And this is probably what a vernal pool looks like. It's a often small forest depression that begins to fill with meltwater in the early spring. And this pool can fill to 6 inches, 8 inches deep, maybe a couple of feet deep. But what makes the vernal pool unique and what makes it a vernal pool is the fact that in most years, before we've reached fall and winter again and there's more snow on the ground, this vernal pool will most likely dry up, at least in some years. There are technical definitions of vernal pools based upon the context. For example, in states like Massachusetts, where vernal pools have a legal status that gives them protection, there's a very, very specific definition. But broadly speaking, we can think of vernal pools today in the context of this video as being a type of temporary wetland that at least in some years will dry completely. Why is that drying completely so important? Because pools that dry completely preclude the presence of fish. Fish populations cannot become permanent and established in pools that dry. And that's true about fish. It's also true about other aquatic predators. And so these temporary pools are often predator-free or almost predator-free, allowing certain species of amphibians to breed in them and have much greater breeding success than they would in an aquatic environment with more predators present. But the fact that this pool will dry completely means that the salamanders and frogs are in a big rush to get their life cycle finished as quickly as possible, because if the pool dries before their larvae have completed their metamorphosis and become adults, then they will be too late. Now, amphibians, because they're such a time crunch, begin the process of mating and taking advantage of these pools early. And the movements of wood frogs are often the first of any of the vernal pool breeding amphibians and are triggered by the first warm, rainy nights of spring. Now, warm in the context of early spring really just means above freezing. But if conditions are right, if temperatures are above freezing and wet after dark, amphibians will begin to move, even if there's a little snow still on the ground. And wood frogs and spotted salamanders will undertake this incredible mass migration from the forest uplands where they spend the winter to the vernal pools where they breed. And we will talk more about this migration in other videos. It is the focus of North Branch Nature Center's amphibian monitoring program. But the wood frogs and the salamanders continue their journey, sometimes moving hundreds or thousands in a single night to a single pool. And there they will begin the process of courtship and selecting a mate. This, in the case of the wood frog, can be a very noisy process. Wood frogs will sing, and their songs can be heard from a half a mile or more away from pools in the right conditions. And so you can often hear a pool in the distance, even if you can't see it. But males will proclaim a territory of their own. They'll sing, and after they've attracted a mate, if a female is interested, she will choose that male, and mating will begin. The female will find a piece of emergent vegetation, typically a blade of grass or a stick or anything that's submerged beneath the water surface, and she'll begin to lay her eggs, affixing it to that emergent vegetation. And as she's laying the eggs, the male will fertilize them. Now, as you can see, these eggs expand very quickly, and shortly after being laid have already become larger than the female who laid them, and they will continue to absorb water and expand for up to a couple of days potentially. This is an egg mass of a wood frog right after it was laid. The eggs are very compact, but very quickly it expands. And here in the middle you can see a young mass next to an older mass on the left to see how greatly they increase by size. Each of these wood frog egg masses can contain up to 700 individual eggs, and wood frogs will often cluster their masses all near each other within one corner of the pool. Some studies have shown that clustering the egg masses will cause them to absorb more solar radiation, keeping them warmer and allowing them to develop more quickly. So when you see these wood frog egg masses all clustered together, this is actually an evolutionary adaptation to allow them to develop quickly. Because like we said in the beginning, this vernal pool is not going to be here forever. They need to grow up before it dries up. Now, the process for the spotted salamander is somewhat similar, although there is no singing. Salamanders will gather in big groups and perform a courtship ritual of their own, where females will select their mate. And then after the mate is selected, they will travel together to a part of the pool, and the male will deposit these spermatophores, or little sperm packets. The female will pick up the spermatophore with her cloaca and hold onto it and use it to complete fertilization. Now here's a female spotted salamander laying her eggs, and like the wood frog, those eggs are laid on an emergent piece of vegetation, and then after being laid begin to absorb water and expand. Here's a look at a couple of egg masses, and notice on the egg mass on the left there's a leech crawling along the egg mass. These spotted salamander egg masses were laid in a semi-permanent pool that in some years does keep its water all year long. As a result, more predators have begun to establish within this pool, and hence there are more predators that the spotted salamander needs to worry about eating its eggs. And so this is a good demonstration of why it's so important for these amphibians to find vernal pools that dry up and preclude predators to increase their chances of having their eggs develop successfully without being succumbing to predation. Here, one more picture to show an extreme difference between two egg masses. On the right, we have an extremely old wood frog egg mass, probably a month old, where the eggs have hatched and it's covered with this dark, thick green algae. On the left, we have two variations of spotted salamander egg mass. On the lower left, that cloudy egg mass is actually just a normal color variation that spotted salamander egg masses can take. But this shows how the timing of migration for different vernal pool breeding species can vary based on weather conditions, and we will revisit this again in another video. Now, as the eggs grow, you can begin to see the larvae inside, and after just a couple of weeks, these larvae will hatch. Inside these wood frog egg masses, you can also see a symbiotic algae growing right there next to the larva, or tadpole. Similarly, in the spotted salamander egg masses, you can see the larvae begin to take shape, and you can also see that green algae. And interestingly, in a recently published study within the past few years, some researchers discovered that the symbiotic algae is actually embedded within the cells of the spotted salamander. And this, as far as I know, is the first and only instance of a plant cell living within, embedded within, the cell of another vertebrate organism. A very unique and special thing about the spotted salamander. And at this point in time, as the eggs are growing and developing, this is what it might look like above the water's surface. It's still early in spring. Leaf out has yet to occur. Some vegetation on the forest floor is just starting to come in, and spring looks very, very early above the water surface. But like we said, below the water surface, things have moved along quite a bit more quickly. And as the weeks go on, the eggs will hatch. When they are small, when they are first hatched, they are very, very small. And you can see in this picture on the left some mosquito larvae for size reference. But they go quickly, they grow quickly, and within a month or two, based on weather conditions, they will begin to grow back legs and then front legs. Their tail will begin to be absorbed into their body, and they, after just a couple months' time, will exit that vernal pool and leave as young adult frogs. Salamanders similarly will grow very quickly. They will take on a form more similar to their adult form earlier, although notice the external gills that this salamander larva uses to breathe. Differently from the wood frogs, however, these salamanders are predators, and they are looking to eat other insect larvae, potentially wood frog tadpoles, and even maybe other spotted salamander larvae from the vernal pool that they live in. The wood frog tadpole's diet, however, includes algae and other decaying organic debris. And they are in a rush because very soon this vernal pool may dry completely. And in some years where conditions are extremely dry or even within a drought, the pool will dry before the young have had a chance to develop. And it's not uncommon in dry years to see this, the dried up vernal pool bed with those eggs still there. But Wood frogs and spotted salamanders are fairly long-lived amphibians, and they're quite resilient to short-term drought. And even if they have a couple years where their productivity is zero, if that third year is nice and wet and they're able to complete their life cycle, you will see young wood frogs like this exiting the pool. And after wood frogs and spotted salamanders complete their metamorphosis and exit the vernal pool, they will spend the rest of their life in the forest, except each spring when they return to the pool, most often the pool where they were born, to breed and continue the life cycle of the vernal pool. Thank you very much for listening. And for more information on amphibian migration, which I alluded to, we will have more videos soon. Thanks so much.